solving problems using trigonometry. And in this lesson, we're going to be looking at angles of elevation and depression. So when a person looks at an object that is higher than the person, the angle between the line of sight and the horizontal is called the angle of elevation. So here's the person standing here at this dot. That's where their eye is. This is our horizontal, and the angle that they tilt their head back to look up at an object is called the angle of elevation. When the object is lower than the person, the angle between the horizontal and the line of sight is called the angle of depression. So if you're standing on top of something, you look down, the angle that you tilt your head through is the angle of depression. They are always measured from the horizontal. So have a read of this example. So if this is our building, and here's the ground, and here's my point P, which is 30 meters away from the building. The angle of elevation, the top of the building, is 41 degrees. The building is at right angles to the ground, and I want to find the height of the building. That line looks like it's missing the top there. So first I need to label the sides. Here is my right angle, so here is my hypotenuse. We always do the hypotenuse first. Here is my reference angle, so this is my adjacent and this is my opposite. I've got to be careful here because I've called this h for height, but I don't want to get that h for height mixed up with h for hypotenuse. I remind myself of SOHCAHTOA, and I look at what I need from my triangle. I've got my adjacent and I need my opposite. Opposite and adjacent means I'm going to be working in tan. So tan theta equals opposite over adjacent. Substitute in the things I know. Multiply both sides by 30. And then put this into my calculator, and to the nearest meter I get h equals 26. Pause the video now while you have a go at question 10. Here is your answer, and I'll give you a moment to read the next example. So we have a cliff and the sea. The cliff is 100 meters tall. A person, we imagine their eye is on the corner of the cliff, not a little bit higher, looks down at a ship, and the angle of depression measured from the horizontal is 17 degrees. I want to know how far the ship is from the base of the cliff, so I want this distance. Now at the moment, I've got my 100 and my D, but I don't know any angles within this triangle, so I can't work it out at the moment. But this horizontal line that I've measured my angle of depression from is parallel to the sea level. And so using alternate angles, remember they make the Z shape, I can see that this is also 17 degrees. The base of the cliff is at right angles to the sea, so now I have my right angled triangle. I'm going to label the sides. This is my right angle, so this is the hypotenuse. This is my reference angle, so this is my adjacent side, and this is my opposite. I remind myself of Sokotoa. This triangle involves O and A, so it's going to be tan, which is opposite over adjacent. Substitute in the things I know. This time the thing I'm trying to find is in the denominator, so I need to start by multiplying by it, then divide by tan 17. Then I put this calculation into my calculator, and to the nearest meter I get 327 meters. Now you're going to work through questions 11 to 15. Make sure you read them really carefully and draw really good diagrams with labels for each of them, because some of them are a little bit confusing at first, but your diagram should help it be really clear to you. If you have any questions, make sure you ask. Here are the answers. Thank you.